If you are running Proxmox on a single machine and you want to set up Proxmox Backup Server, the first thing you will find is that it needs a second host. And if you do not have one, it feels like you are stuck. But here is the thing. If you already have TrueNAS virtualized inside that same Proxmox host, you actually have everything you need. And that is exactly what we are going to set up in this video. Now I know what you are thinking. Keeping backups on the same machine you are trying to protect makes no sense. And normally you would be right. But this is where TrueNAS changes things. When you virtualize TrueNAS inside Proxmox, you pass through a separate set of physical disks directly to it. Those disks belong to TrueNAS, not to Proxmox. So even if the Proxmox host goes down, those drives and everything on them stay untouched. That is what makes this setup actually safe. So what we're going to do is virtualize Proxmox Backup Server inside Proxmox, connect it to a network share from TrueNAS, and use that as the data store. Every backup goes straight into TrueNAS onto those separate dedicated disks. And the only other thing we need to protect is the TrueNAS configuration file, which is just a small file you can save to Google Drive, your laptop, or anywhere else. Now, with all that covered, let's get into the actual setup. The first thing we need to do is get Proxmox Backup Server running as a virtual machine. Now, I have already covered the full installation process in a previous video, where we go through the ISO download, creating the VM, going through the installer, and the initial configuration. You can find that video in the I button, and I will also add it in the description below, so make sure to check that out first until you are done with the initial setup. But before you follow that video, there is something I want you to note. When you get to the disk tab during VM creation process, we used a disk space for storing the OS as well as the backups. But for this setup, we will only be storing the OS in that disk. So if we check the official documentation, the minimum requirement is at least 8 GB, but if you have the storage, it is recommended to have 32 GB. And by default, Proxmox already suggests 32 GB, so you can just leave it as it is and move ahead. The reason we are not going any bigger here is because we will not be storing any backups on this disk. All the actual backup data will be going into TrueNAS. So 32 GB is more than enough. Once you have Proxmox Backup Server installed and the initial configuration is done, come back here and we will move on to the next step, which is to set up the storage that our Proxmox Backup Server will use. For that, let's head over to the TrueNAS dashboard. Here, let's go to Datasets. If I expand the storage dataset here, this is where I keep all the datasets, which are used by other devices on my network. Now, before we create anything, let me quickly explain why we are going with a specific storage type here, because this matters. You might already be familiar with NFS or SMB shares, but the problem is both of those are file-based protocols. And if we use them for Proxmox Backup Server, the backup process becomes so slow that it feels almost unusable. Here, a better option is iSCSI, because it is a block-level storage, and it performs significantly better with Proxmox Backup Server. But there is actually something even better available if you are on a recent version of TrueNAS. And I will get to this in a moment when we reach the shares section. For now, what we need is block storage. And to set that up, we need to create a ZVol. So let's select Storage and click on Add ZVol. For the name, I will call it PBS. For the size, I will set it to 20 GB. Now for a real setup, you will obviously want to size this based on how much backup data you expect to store, but I'm keeping it small here since this is just a demo. One more thing before saving, go ahead and turn off ZFS deduplication. The reason is that Proxmox Backup Server already handles deduplication on its own, so having ZFS do it as well would just waste resources without any real benefit. Once that is set, go ahead and click Save, and the PBS ZVol will be created. You can see it listed here. Now let's head over to Shares. And if you are on a recent version of TrueNAS, you will notice something new here. The NVMe-oF section. This is a newer protocol, and it is worth taking a moment to understand why it is a better choice than iSCSI for our use case. iSCSI runs over TCP, and it adds overhead at every step, which limits how fast data can move. NVMe-oF is designed to be much more lightweight, with significantly lower latency and better throughput. Now, technically, NVMe-oF is built for NVMe drives to get the most out of it. But if you see my setup, I do not have NVMe drives in my TrueNAS. I'm using regular spinning hard disks to create my storage pools. But even with that, it seems to be working noticeably better than iSCSI shares. So if you have NVMe drives in your TrueNAS, you will get even better results. But even if you do not, it is still the better option here. So let's go ahead and set this up. Under the NVMe-oF subsystem section, click on Add. For the subsystem name, I will type PBS. Now, next to namespace, click the Add button. Here we need to select the ZVol we just created. Let me expand the dataset list. Then under Storage, let's select PBS. Then click Save. And once we save that, it will automatically take us back. Now let's click Next. On the Access section, under Ports, click Add, and choose the TCP option. It will show your TrueNAS IP address with port 4420. Select that and click Save. A pop-up will appear asking if you want to start the NVMe-oF service on startup. Go ahead and click Start. And with that, the PBS NVMe-oF subsystem share has been created, and you can see it listed here. Now let's move on to configuring Proxmox Backup Server to use that TrueNAS share as its data store. For that, let's switch over to Proxmox Backup Server. Normally, we add a data store from this data store section by clicking on this Add Data Store button. But here, if you expand the data store type dropdown, you will see it only gives us 3 options: local, removable, and even S3. There is no option here for any kind of network share. So this is not something that we can set up from the web interface. But as Proxmox Backup Server is built on Debian Linux, we can mount this network share through the terminal, the same way we would on any normal Debian system. Let's see how we can exactly do that. So let me close this pop-up and then let's move on to the Shell tab. First, let's check what disks are currently available. Type lsblk and press Enter. You can see there is only one disk SDA, which is the VM's own system disk. Nothing else is attached yet. Now, to add the NVMe-oF network share, the first thing we need to do is install a package. Type apt install NVMe CLI-Y and press Enter. By the way, you do not need to type these commands manually from the video. I will share all of them, and you can find the link in the description so you can just copy and paste them from there. Once that is installed, type modprobe NVMe TCP and press Enter. This loads the NVMe TCP kernel module, so the system can communicate over NVMe-oF. Now copy this next command, exactly as it is. And press Enter. What this does is add NVMe TCP to that file, so the module gets loaded automatically on every reboot. Now let's discover what NVMe subsystems TrueNAS is sharing. Type NVMe discovered -t TCP-A followed by your TrueNAS IP address, then -S 4420 and press Enter. And here you can see 2 entries in the output. The one we are interested in is the second one. If you look at the sub-NQN field, you can see it ends with the subsystem name we created in TrueNAS, which is PBS. That is the one which we need to connect to. So press the up arrow to bring back the previous command. Change discover to connect, and then at the very end add -n, followed by the full sub-NQN value. Copy it from the output above and paste it in. Then press Enter. Now let's run lsblk again to see if anything has changed. And there it is, a new disk has appeared, NVMe0N1. That is our TrueNAS network share, now connected and visible inside Proxmox Backup Server. Now let's format it. Type mkfs.ext4, then mention the disk path /dev/NVMe0N1 and press Enter. This formats the disk with the ext4 file system so we can mount and use it. Once that is done, let's create the directory where we will mount it. I want it to be in /mnt/NVMe. Now let's mount it by typing mount, then the disk path, followed by the mount directory path, and press Enter. Now let's check if that worked. Type lsblk and press Enter. It looks like the mount process did not work. And actually, looking at the previous command, I missed the / before MNT. Let me press the up arrow to get that command back. I will add the / before MNT and run it again. Now let's check again with lsblk. And this time you can see the mount point is showing up for NVMe0N1. So the drive is now mounted. But before we actually use this, we need to make sure this mount survives a reboot. For that, first we need to get the UUID of this drive. Type blkid/dev/NVMe0N1 and press enter. And here you can see all the attributes of this drive are listed. We will need this UUID from here to add this drive to FS tab file, so it mounts automatically on every boot. Type echo, then add double quotes. Here, we will need to provide this UUID, so let's copy it. And inside the quotes, mention UUID equals, and paste in the UUID you just copied, followed by a space. Then type the path of the directory where we want to mount it. Then follow exactly as I'm doing. This will add these details to the FS tab file. Now type this command to save the NVMe discovery configuration. And press enter. Then type systemctl start NVMe-FC boot connections .service and press enter. Once that is done, press the up arrow to get that command back. Replace start with enable and press enter. And that will make sure the NVMe-oF connection is automatically re-established on every reboot and the share gets mounted back to the same path. Now let's test if it actually works. Let me run power off to shut the VM down. Then let's head back to Proxmox VE, open the console tab, and click Start. Once it boots up, let's switch back to the Proxmox Backup Server and reload the page. And type lsblk. And here you can see the NVMe-oF network share is connected and mounted to /mnt/NVMe, exactly the way we set it up. So this will always work even after a reboot. Just make sure the TrueNAS VM boots up completely before this VM actually starts. You can do that by configuring startup delay of TrueNAS VM in Proxmox VE. Now, before we add this as a data store, we need to make sure this directory is completely empty. So let's navigate to /mnt/NVMe and type ls to list the contents. And you can see there is a lost plus found directory in here. That is completely normal. It always shows up after formatting a new disk. But Proxmox Backup Server requires the directory to be empty before it will accept it as a data store, so let's remove it. Now let's verify it is gone. Let's also do a quick check just to be sure there is nothing hidden in there. Now we can go ahead and add this as a data store. So let's click on Add Data Store. For the name, I will call it TrueNAS, since the data will actually be stored inside TrueNAS. For the data store type, we need to keep it as local, because even though this is a network share, we have mounted it as a local directory, so Proxmox Backup Server will treat it as local storage. For the backing path, provide the directory path where we mounted the NVMe-oF share, which in my case is /mnt/NVMe. The next two fields are for cleanup jobs, and you can schedule those based on your own needs. You can also define how many backups you want to retain from the second tab. Once that is all set, go ahead and click Add. And the data store will be created. Now if we click on the TrueNAS data store and check the summary, you can see the disk size is showing around 20 gigabytes, which is exactly the size we configured for the ZVol in TrueNAS. And if we go to the data store tab, the same thing is reflected there as well. So the storage is connected and working properly. Now it is time to connect Proxmox VE to this data store. For that, let's head back to Proxmox VE, navigate to the data center level, then click on the Storage tab. Click on Add, and from the drop-down choose Proxmox Backup Server. Now let's fill in the details. For the ID, I will call it PBS. This is the name that will show up in the left panel. For the server field, enter the IP address of your Proxmox Backup Server. For the username, you can see the format we need to use in the placeholder, which in our case is root@PAM. Then provide the password you have set for Proxmox Backup Server. For the data store field, enter the name of the data store you just created. For me, it is TrueNAS. And for the fingerprint, we need to head back to the Proxmox Backup Server. Grab it from the dashboard. paste it in here. Once all that is filled in, click Add, and that will register the Proxmox Backup Server as a backup storage location. Now let's set up the backup schedule. For that, let's head over to the Backup tab. Click on Add. Now let's fill in these details. For the storage, set it to PBS. For schedule, you can set any time, based on when you want the backup jobs to run. I will set it to 20. Mostly, by this time my system is usually up. For the selection mode, make sure it is set to include selected VMs. Then from the list below, select the guests you want to include. I will check these 2 VMs here. Once that is done, click Create. And the backup job is now scheduled. Now later, if you ever want to make changes to this job, just select it and click Edit. Then make your changes. Like I do not want to back up this VM anymore, I can simply uncheck it and click OK to update the job. Now let's go ahead and manually run this backup job. Right now this job only includes VM 303, so let's make sure the job is selected and then click Run Now, and then confirm it. The backup process has started. You can follow its progress from the task log at the bottom, and you can also see the VM has a backing up symbol next to it. If you want more details, just double-click on the task log entry to expand it. Now, this first backup might take a little while, but if you have ever tried running backups with an NFS share or something similar, you will notice this is significantly faster. And just keep in mind, the first backup always takes the most time, because it has to capture everything. From the next run onwards, it will only back up the changes, since Proxmox Backup Server uses an incremental backup process. The backup is now complete, and it took around 273 seconds. And if we check Proxmox Backup Server, you can see it is occupying around 9.5 gigabytes out of the 20 gigabytes TrueNAS CVOL, which is around 43%. If we go back to TrueNAS and check the details for this CVOL, you can see a similar percentage there as well. Now, do not worry if the numbers do not match exactly between Proxmox Backup Server and TrueNAS. They can differ for various reasons, including the deduplication happening on the Proxmox Backup Server side. But what matters is that both are showing data, which means our setup is working. Now let me show you the deduplication feature. Let's head back to Proxmox, and let's edit the backup job. VM 302 is a similar Ubuntu Cloud Init VM, so the OS underneath is exactly the same as VM 303. Let me check VM 302 as well, and then click OK. Now let's make sure the job is selected and click Run Now. The backup job has started. Let me expand it from the task log and wait for it to complete. VM 302 took around 29 seconds to back up, since it is a new VM, which we are backing up for the first time. And VM 303 was even faster this time, only around 15 seconds, because it only backed up the changes since the last run. So we have now backed up 2 VMs with similar disk sizes, both running Ubuntu Cloud Init. But if we go to Proxmox Backup Server and check the space, VM 303 was already occupying around 9 gigabytes from the previous backup, and now with a second VM added, it has only gone up to around 10 gigabytes. Just 1 gigabyte more for an entire second VM. That is because of the deduplication feature. The deduplication factor is only showing 1 right now, but over time, as more backups accumulate, you will start to see just how much space Proxmox Backup Server can save you. And if we go to the TrueNAS Datastore tab, you can view all the details from here as well. There are quite a few options available, but I will not be covering those in this video. So at this point, our backups are being stored safely inside TrueNAS. But now we need to look at the restore process. So let's head back to Proxmox VE. And now let's see how we can restore a VM from these backups. Let's click on the PBS storage and go to the Backups tab. Here you can see all the backups that have been captured are listed. Let me select the backup for VM 303. Now, if you just need to recover some specific files or directories, you can click on File Restore. And here, under Drive SCSI 0, if you expand the partition 1, you can see the entire file system of that VM, right here in the browser. All the files and directories are listed, so you can just select the ones you need and download them directly from here without having to restore the entire machine. But if you want to restore the entire VM, click on Restore. It has already picked up an available VM ID, but I will set it to 501. You can also override the name. I already have the original VM still running, so I will rename this one to Restored. Then click on Restore, and it will start the process. Once it is done, you can see a new VM has appeared here with the settings we specified. Let me go ahead and start it. And as this VM already had the QEMU guest agent installed, we should be able to view the IP address right from here. Let me open a terminal and SSH into it. The fingerprint has changed, as this is a new VM entry, so we need to clear that and reconnect. And once we are in, you can see all the Docker containers are running, exactly the way my dev VM had them. So the restore process works perfectly with a backup stored inside TrueNAS. Now that covers VM level failures. But what happens when the Proxmox host itself gets damaged, and we need to recover from that? Proxmox Backup Server does not back up the host itself, so we will need to reinstall Proxmox anyway. But once that is done, all you need to do is virtualize TrueNAS again, pass through the same disks, and restore TrueNAS from its backup file. If you want to understand that process in detail, I have a separate video on TrueNAS backup and restore. You will find the link in the I button, and I will also add it in the description below or pin it in the comments. Now let me show you how exactly can we recover our VMs in case of a complete host failure. First, let me delete this restored VM. And then let me remove all the Proxmox Backup Server related configuration from Proxmox VE, so we are starting from a state, which is just like a fresh install. For that, let's go to Data Center, then the Backup tab, select the backup job we created, and remove it. Then go to the Storage tab, select the PBS storage entry, and remove that as well. Now let me also shut down the PBS VM, and then remove it too. So now our Proxmox VE is completely clean. Now let's assume this is a fresh install of Proxmox VE, and we have already virtualized TrueNAS again with the same disks passed through. The first thing we need to do is create a new VM for Proxmox Backup Server, just like before. Then go through the installation process and the initial configuration, setting up the repository, updating the packages, and getting the system ready. Once that is done, now comes the important part. Open the shell, and first let's install the QEMU guest agent. Then go through the exact same steps we did earlier to set up and mount the NVMe-oF share from TrueNAS. But here, there is one thing you need to be very careful about. Do not run the mkfs.ext4 command this time, because our backup data is already on that disk, and formatting it will wipe everything. Every other step is the same, just skip that one command. Once the share is mounted, if you navigate to that directory, you will see all our previous backup files are already there. Now to use those files, let's click on Add Data Store and fill in the configuration the same way as before. But here you will remember that earlier I mentioned the directory needs to be empty for Proxmox Backup Server to accept it. Since our directory already has backup data in it, we need to handle this differently. So check the Advanced checkbox, and then enable the Reuse Existing Data Store option. That is the only difference from what we did before. Then go ahead and click Add. And once the data store is created, you can see all the previous backup files are listed here. Everything has been recovered inside Proxmox Backup Server. But let's verify it actually works from Proxmox VE as well. For that, let's head back to Proxmox VE. Go to Data Center, then Storage, click Add, choose Proxmox Backup Server, and configure it the same way as before. Once it is connected, click on the PBS storage, go to the Backups tab, and all our backups are right here. Let me go ahead and restore one. I will fill in the details and also enable the Start After Restore option this time. And it looks like it is working. The VM has been restored and automatically started. Let me SSH into it. Now if we check our Docker services, all the Docker services are running, which means the restore was fully successful. And just to mention, I have also tested taking a backup from one Proxmox host and restoring it into a completely different Proxmox host using the same setup. And it works just as well. So if you were trying to get Proxmox Backup Server running on your home lab, but you were held back by having only a single device, now you have a way to do it. As long as you have TrueNAS virtualized inside your Proxmox host or running somewhere on your network, you can virtualize Proxmox Backup Server alongside it and have a proper backup solution without needing a second machine. If this video helped you, make sure to hit the like button. And if you run into any issues while setting this up, feel free to drop a comment below. I read and reply to all of them. You can also join our Discord server if you need help more quickly. We have a great community there that is always happy to help. And if you want to try a different approach to this, like running Proxmox Backup Server inside an LXC container instead of a VM, make sure to check out my next video where we do exactly that. Thanks for watching, and I will see you in the next one.